Okay, so we're going to talk in this unit about exponents and logarithmic expressions, equations. So we're going to start by recalling some stuff with exponentials. Okay, so lots of this comes from grade 9 and 10. I know we didn't do much of it in grade 11. Anything to a 0 power is 1. Anything to a 1 is itself. 2 squared is 4. 2 cubed is 8. Keep multiplying by 2. Another 2 in there is 16. 32. Okay? All right, now negative exponents. Negative exponents, what do you do with negative exponents? Do you remember? What's the negative exponent rule? My grade 10s are doing it right now. Alternate?
Well, don't you do, if it's the 3, then it'd be negative.
Is that what you're thinking?
Yeah.
Okay. Okay, if you ever have a negative exponent, it basically changes locations. And now it's a fraction, 1 over 16. Okay, and so this has a negative exponent. So it would technically move like that. So a negative exponent would move. And then what is 3 times 3 times 3? 27. Okay, we're going to talk about radicals. So this is the square root of 9. I know that you know that that's 3, or hopefully you know that that's 3. I want you to understand that the square root of 9 is the same exponent as a 1/2 exponent. A square root is the same as an exponent of 1/2.
I can't see that right.
What? Because it's fuzzy?
No, like that 1. It says equals 1.
1.
Okay.
Like that?
Yeah. Oh, I could have done that.
You could do that math. 3 times 3 times 3. You got it.
I know better.
I think something was on his mind.
Okay. This is the cubed root of 27. Does anybody know how else I could write a cube root as an exponential? 27 to the... that 1/3. So radicals become fraction exponents. So this would be, what is the cubed root of? So 3. So this is the equivalent to this. See? So recognizing this. And do you know that one? What times what times what times what gets you to 16? 2. Okay, so now 3 squared equals 9. We've been doing this kind of stuff long time. It's an exponential equation, right? So we think about inputting the exponent. So if the exponent was 2, then the result is 9. Okay, that's kind of like an x and a y, right? We usually input x and we get out y. We've been doing that our whole math career. Logs switch everything around. Okay, so now this is an input. So, sorry, this is the output of the other one, but now it's the input. And this was the input, but it's now going to become the output. So it's weird for your brain to say at the very end it equals, and then we're going to answer the exponent. Usually we talk about math, we say here's the result. But this time we're going to answer what's the exponent. Okay, so here is how we always do logs. Log base result equals, and then we're trying to figure out what the exponent was. Okay, so here we go. This is a base and this is a result. So this is what I'm trying to get you to figure out. 3 to the what equals 27. That's what your brain is doing, but backwards. So I'm saying, what's the exponent? 3 what is 27? 3 cubed. Okay, so your brain is thinking backwards today. 16 is the base. What is the exponent that will produce a result of 4? 16 to the what would give me a 4? 16 to the 1/2. Because it's a square root. Square rooting 16. And then a square root of 16, right? Okay? Square root of 16 is 4, but we're not talking about radicals. We need exponents. So this radical is the same as that exponent. Okay, so here, 8 is a base. What would give me a result of 2? Anybody think of an idea? One over 3. Yeah, fraction. Okay?
I didn't see that coming.
Because what kind of math are you really doing? You're doing the cubed root. You're doing a cubed root. But I can't do a radical. So what is that equivalent to? Cubed root is the same as an exponent 1/3. Okay, next one. The base is 8 to something would give me a 1 over 64. So what kind of exponent would I have needed up there to make that happen? It ended up as a fraction, so you got stuff at the top here. What happened when it ended up as a fraction? Negative. Yeah. The negative rule makes something switch. So you really have to go back to knowing these fundamental rules at the top. Okay, this is from grade 9 and 10. Okay, base 9 to what would make 1/9? So looking at the answer, it changed positions. What happens when something changes positions? Negative. Did you think -1? Okay, and the last question, the base is 6 to something makes 1. What would the exponent have to be? 0, yep. 6 to a 0 gets you to 1. Okay, so rules. Okay, the next part's graphing. I'm going to flip. Flip a few pages, flip. There's a big graphing part, so we're going to skip graphing today. Okay, above this chart, we're going to go like this. If you're an exponential, exponentials have a base to an exponent equals a result. Base to an exponent equals a result. Log is now the log of a base result equals exponent. Okay, they all have the same parts, we just move them around. So I did the first one for you. Okay, you can see where I put the base of everything, the result, the exponent. Okay, so I need you to take this exponential and write it as a log. So log of little base, the result equals what exponent? So I need to change this to an exponential. So the base is 2 to the exponent 7 equals result. Okay, so the next one, log of the base result equals exponent. Okay, so exponential shoots out a result, logs shoot out an exponent, right? So then this one is the base of 2, exponent 4, result 16. Okay, estimating logs. So the base is 2. I'm trying to figure out the exponent x, and the result was 40. Okay, so an estimate, I'm not allowed to have a calculator. So on your provincial exam, this would be on the section without my calculator. Do you guys know any 2 to the somethings that could get us close to 40? 2 to the 5 is what? 32. What would 2 to the 6 be? Can you multiply this by another 2? 64. So the exponent on this was 5. The exponent on this was 6. Does anybody want to estimate, this means estimate, the value for this x exponent to get to 40? To one decimal place. 5.3. Good. I like it.
What's that sign?
Yeah.
Approximately equal to. Woo, good guess. This is what it is. I'm not going to show you how I do that because you're not allowed to know.
Speedball. Are you really going home to watch TikTok for an hour?
You got it.
We're only leaving at, I doubt it. We're only leaving at 5.
Okay, next one. Okay, I want you to notice something. This equation this was an equation. It said I want to figure out what x equals, kind of idea, but this one isn't that. So I'm just going to put a question mark up there. And let's talk about a 6. What do we know? 6 to the 6 squared is 36. That's way too low. 6 cubed. Anybody know that number just because they know it without their calculator? 216. Okay, so what is your prediction that exponent would be? It's going to be 2 point. Where are you leaning closer to? 2 point, so approximately equal to 2 point. 2.6? Well, you had a good guess last time, so.
How are you getting?
Dude, this is wild.
Okay. Do you notice what's up? I'm not showing you my.
This number. What are we doing to get 2.6?
Because
Yes.
I knew
It's an approximate guess, right?
I knew 2 squared gave me a 36, and 2 cubed gave me that.
Also, we're guessing the exponent.
You're guessing the exponent.
You're close. Let's see if we can get the closest on the
I'm
next
guessing the exponent. Okay? Yeah, because look at what log equations. You know what I mean? This is a log. What does it shoot out?
Exponent.
It shoots out a exponent, right?
one. What does log stand for?
Logarithmic. Okay, so do you notice something? Here I used an x, and here I didn't. So if you wrote me x equals 2.6 on this one, I have to deduct 2 points. Okay? I also get this. I get people who write me 6 to the 2.6 equals to 125. Okay? This is also a deduction in communication. Because I want, what is the exponent? Number. I just want, give me a number that the exponent is. Okay? Okay. Solving equations. Okay, everybody knows their parts now? Base, result equals exponent. Okay, can you take this from a log and turn it exponential for me? Can you move all the components around? It's a log. Can you change it? So 5 base squared equals result. Does that make sense? Base 5 squared equals result. Good? See, I just moved it all around. Okay, you can solve that. Super simple algebra. Just isolate the x there. Okay, now I need to tell you something about the results. The result, whatever you have in a log, and the result can never be negative, ever. You can be 0. No, I'm just kidding. I don't want to say it like that. It can't be 0 either. I'm going to, sorry if you wrote in pen. I'm going to rewrite that. You can't be negative, but you also can't be 0. So I'm going to rewrite that as you always have to be positive. You always have to be greater than 0. So if you put a 6 into this result spot, are you going to be positive at the end of that? Right there? Yeah. Okay. Give me a rearrangement. Go ahead. Base to an exponent equals a result. Base to an exponent equals a result. Okay, so give me some algebra stuff here. Big shiny moment. Please tell me you know what the big idea is. What? Equals 0. Do you have simple trinomial factoring stuff to do, right? Lots of past algebra will come into place. Okay, before I say that they're answers, we're just going to check. If I were to plug this in to just this section, the result section, if I plug -9 in there, would this come out positive? -9 squared plus 5 times -9, would that be a positive number? Yes. So it's good. 4, also positive, so it's good. Sometimes you might have to just say that's not allowed. Okay, last one. Base exponent equals result. Can you move them all around? I wanted to now change the format. Give me an exponential out of that. Okay, so here's some stuff about exponents. I would like to end with x equals, right? That's how I would like to end this question. Would you understand that basically what I would like is this to be a 1 up top instead, right? That's the goal. What can I put there to cause a 1 on the exponent? 4/3. Is that what you put? So that means I have to do a 4/3 on the other side. Okay, now we learned that a 1/3, right? We learned that 27 to a 1/3 is the same as a cubed root. Okay, what is the cubed root of 27? What's a cubed root of 27? 3 to 27 to a 4th. That was something you learned in grade 10, right? To change that to that. So the cubed root of 27 is 3. 3 to the 4th equals, can you do that without a calculator?
81.
Without a calculator?
I didn't use it.
81.
9, 81. Okay, page 9, question 6. Okay, this one, log of 350. I have a problem. There's no little tiny base number in the. This is a result. I'm going to try to figure out the exponent, but there's nothing in the little base position. Okay, so here's a secret. If there's nothing in the log base position, they work with a 10. There's a secret 10 there. Okay, so I'm going to show you, here's why. You actually have a log button on your calculator. So the log button uses a base 10. So let's go with the log of 100. log of 100, what should I get? 2, because 10 squared, right? Okay, here's the problem. You don't have a calculator on this question on your exam. So I know that 10 squared is 100. What's the next 10 exponent you know? Do you know what 10 cubed is?
No.
1,000.
1,000. So therefore, what kind of exponent number should we be at? Something bigger than 2, but less than 3.
2.15.
Okay, well, it's not exactly 2, because it's not exactly 3.
2.8.
So basically, is 350 closer to this end or this end? Closer to this end than that end. Okay, I'll do the next one with you. Okay, so 2 to the what is 40? Again, no calculators allowed, so 2 to the what equals 40. That's what I'm going to think about. What's the exponent? Okay, here's what I know. I know 2 repeated 5 times is 32. I know 2 repeated 6 times is 64. So what do you think is a good number to pick to get to 40? 5.2 you say? 5.2-ish? Okay, now this one, base 5, something would get me result 125. That is a for sure one. What is that exponent? 3. 3. So I'm supposed to add these values together. So if I added this plus this, which number is the closest to my adding? 8. Because we guessed, we knew exactly. Okay, flip. Page 10, number 9. Page 10, number 9. Okay, I need you to do this one for me. Okay, so what is your brain doing? Base 3, what exponent results 27? That's what your brain is doing. 3. Okay, so now the question will change. What is log 9, 3? So what is your brain doing? Base is 9. We're trying to figure out an exponent to get 3. 1/2. Remembering because a 1/2 is an equal to doing a square root. Okay, flip to page 11. Okay, this one more thing to add because there's always these crazy things. ln is the same. ln is the exact same thing as doing a log e. E is a number in math. You've probably never seen it before, maybe science? No? Okay. So you know how if I say pi, you probably are like, hey, that's 3.14 da da da, right? You have an e number. is 2.72-ish. Okay, so we've been talking about logs. When they use a base of e, so a log of a base e, it's the exact same thing as doing a natural log. Okay, so this is replaced with that. So I'm going to replace the natural log with doing a log e. Okay, so what is the answer? What is your brain going to think? If you had a base e, what exponent results in e? If you have a base of e, what exponent makes you result in an e?